Okay, in the last video, we already finished chapter 1. So now it's time to work on the practice questions of chapter 1. But before we proceed, I do have a few quick words on those practice questions. Let's call them guidelines. So first, practice questions are highly recommended. Okay. However, they are not mandatory. So if you really don't want to solve, it's your choice, right? I can't force you to study, but personally, I actually recommend you to work on all the practice questions. Okay. So my personal suggestion is to work on all questions. For example, there are 20 practice questions for chapter 1, right? Well, they are, I don't think they are that many, right? 20 questions for one chapter. I would say that's somehow a little over the minimum requirement for each chapter, and especially many of you, or even most of you, are majored in actuarial science. You will need to take some SOA exams. Right? FM is likely the first one. So working on those questions will definitely help you prepare SOA exam. So that's another advantage of working on those questions. But they are not mandatory, and they are not graded towards final scores. So only 3 tests and the final exam count. Okay, so those practice questions, they are highly recommended, but they do not form part of the evaluation. The reason is simple, because there are solutions out there. So I don't want you to Google the solutions and submit them to me. But if you hand in your work, I will grade. Okay, I will grade and well, possibly give you some feedback. So not giving you homework is not me trying to work less. It's I'd rather to leave this to you, because in the past, some students say I tend to give too much homework. Personally, I really don't think so, because for SOA exams, it's a lot more challenging than what we are doing. So in order to really prepare you well for SOA exams, in fact, I should increase the workload. But obviously, I don't want to anger some of you, so I leave this as optional. If you really don't have time, or if you don't like actuarial science, at least you have a choice. Okay. But for any of you who submit, I will grade. So if you haven't worked on those questions yet, you can try those questions first, right, before watching this video, right? Because now it's pre-recorded, you can watch anytime. Please do not watch this video before, okay? Before you have tried those questions, okay? Finally, you should watch the lecture videos of practice questions later. So basically, after you have tried on them, okay? Tried on solving them. So here are some, quick guidelines. At least that's something I hope you to do. So I will pick some from the textbook and solve them during the lectures. Okay, and of course, there will be some of them I will not cover, and if you have questions, please feel free to ask questions on those I don't cover. Okay, so because I recommend you to solve, if there are questions from those I haven't showed you, so feel free to ask me those questions. So now let's officially start the questions of. So let me get my notebook. Okay, so let's study. The first one is from the list I give you is 1.2. So let's read the question. Fund P earns interest at a simple rate of 4%. So fund P, simple rate of 4% a year. Fund Q earns interest at a simple interest of I%. If you want, you can, let's put IP, okay? For another fund, it is also simple interest rate, and unfortunately, we don't know exactly the rate of fund Q. It is only I%. 100 is invested in P, and 118 and 50 cents is invested in Q. The accumulated amount in two funds will be equal after 5 years. So if you want to denote 0 to 5, 0 to 5, right? We know the AV of those two funds will be equal. So 1 plus IT, T is 5, okay? Since they are equal, I directly equate. The starting amount is 118.50, 1 plus I, 5, okay? The time is the same, 5 years. Interest is different because the starting amount is different. So we are trying to solve this equation, right? So this is rather straightforward. From calculator, you can get this amount, okay? Divided by 118.5 minus 1, and then divided by 5. So you get the result. So for instance, what we are trying to solve is 1 over 5. This is 100 times. So 4 times 5 is 20, right? So it's 1.2, so it's 120. Divided by 118.5 minus 1, so get the result. The next question is 1.4. Here, we also have two funds. Fund P earns interest, but now it's compound interest rate. Compound interest rate, 4%. So let's also use IP. We have a second fund, fund Q. Similarly, it is also compound interest rate. We don't know the rate yet. Everything is the same number, the same 5 years. So now we do this, 1 plus I, which is 4% to the power of 5, 118.5, 1 plus I to the power of 5. Okay, so the form of interest has changed from simple to compound. So everything is pretty much the same, but the computation is slightly different. Okay, so in order to get I, so we divide this number to the left-hand side. So close this divided by 118.5. Okay, and then let's take power of 1 over 5. Then it will cancel 5, right? So finally, subtract 1. So it's 100 times 1.04 to the power of 5 divided by 118.4. So this taking power of 105, you can write it as decimal, which is 0.2 minus 1. Okay, then you get the result. Okay, so by the way, the final result is about 0.25%. So it's a lot less than 4%. Here, if you try, this is about 0.53%. So again, you know, my preference is to write the interest rate in percentage and to keep 2 decimal places. The next one is 1.6. Your great-great-great-grandfather set aside $10 on July 1st. So here's July 1st, 1876. In an account paying 5%. So amount is $10. Paying 5% annual effective. So we treat as compound. Assuming no additional deposits or withdrawals were made, what is the account balance on January 1st? January 1st, 2004. How much it is worth? What would the account balance have been if the account had been paying an annual effective interest rate of 10 instead of 5? So basically, we want to know how money accumulates from quite far away to 2004. Okay, the question itself is very easy, right? We know the interest rate. We know it's compounding. So we know the formula, right? And we know the starting amount is just the $10. So the question boils down to, so let's say this is AV. I don't know what exactly T is. Let's call it T. So the only question right now is, what is T? How many years, you know, from that far away to 04, okay? So they are, what I usually do is, because at the end is well, you can think that is the first day of 2004, or you can think the last day of 2003. It's almost the same. But the starting time is January 1st. That is not good, right? We want the starting time to be January 1st instead of July 1st. So we move to the nearest January 1st, which is January 1st, 1877. Then we can break the entire timeline into 2 parts. From the starting time to the nearest January 1st, and then from this January 1st to this January 1st, okay? So obviously for the first period, it's half a year, right? Because that's basically the second half of the year. So we know it's 0.5. How about this period? Again, you know, if you have something very, very far away, you can't draw the graph, it doesn't matter, right? So you can use this simple idea. Let's say 1, 2, 3. January 1st, 02, January 1st, 03. I'm just giving an example. January 1st, 04, January 1st, 05. Okay, how many years? Obviously, they are 3 years, right? 1, 2, 3. Okay, how do I get 3? 05 minus 02, right? So this will be 2004 minus 1877. So if you do the math, this will be 127 years. So basically time t is 127.5. Uh, when you use the end time minus the starting time, make sure they start from the same date. Okay, otherwise you cannot just do the subtraction. So once that is known, that is very easy, right? Next, you change I from 5% to 10% to do the next question. So the real tricky part is to figure out the time span. Okay, anytime if the period is too many, well, you don't need to use that many to give you the idea, right? You can just use 2 or 3 to see how I should use the starting and the ending time to figure out the time period in between. Next one, 1.10. A 15,000 car loan is repaid with one payment of $18,375 plus 65 cents after 36 months. What is the annual effective discount rate? Discount rate. Okay, read the question carefully. At the beginning, the loan is, or you can switch this angle because to the borrower or to the lender is money out. So the lender will receive 18,750.65. Okay, over 36 months. That is 3 years. Right. So here it's 0, here's 3. I want to know the annual effective discount rate. So the easiest way is to figure out the 1 year discount factor, because I know this is right, and between nu and d, I have this relation that is nu equals, or v equals 1 minus d, right? So I can keep writing. So this is 1 minus d to the third. Okay. So from here you can, okay, obviously you can divide this to the other hand side. Okay, and then take 1/3. Then this will cancel this, right? Then d equals 1 minus copy 1/3. Okay. What is the result? I have the result is roughly 6.54. So of course, there are many different ways to solve this question. I'm just providing you one of them. 1.13. So in this question, we want to find the accumulated value at time 5 years. The amount, $30, that is invested at time 0. Use a force of interest. Okay, so this is a function, 0.02t plus 0.01. Okay. So this is invested at time 0. So that's my bad. So now $30 is invested at time 0. You want to know the worth of this account at time 5, given that you're going to use continuous interest with a varying force of interest rate. So AV5 equals 30 times exponential from the starting time, which is 0, ending time, which is 5, force of interest 0.02t plus 0.01. We are taking integral of this function from 0 to 5. So So again, this is a power function, so it becomes 0.1 t to the second plus 0.01 t from 0 to 5. Obviously, 0.01 can be factored out, right? 0 you don't need to consider because plugging in is just 0, so it's 5 squared, which is 25, plus 5 is 30, so it's 0.3. Right. So it's actually suggested to try most of the calculations on your own, like by hands, right, rather than always rely on calculator, because it's at least it's my personal experience. It's that we tend to make calculation mistakes by punching the numbers on the calculator. At least it happens to me quite often when I try some SOA questions. Sometimes they are tricky, in setting the numbers. So even I get all the formulas correct, I hit the buttons wrong. So in order to help you so basically to avoid that kind of problem, you should have a quick idea from your hand calculations to see, oh, this should be roughly in this range, right? So that you have some kind of sixth sense on the final result. Okay. So this is question 1.13. The next 4 questions are actually SOA questions, and I think I will leave it for the next video because those 4 questions are a lot more involved than those I just showed to you. So I will stop here, and probably that's good also for today's lecture. So although it's slightly less than 75 minutes, but I have been using more than 75 minutes in the previous lectures, and I start to get a timer. So hopefully in the future I will keep the lecture length to be somehow very close to 75 minutes. So I will stop here and come back next week.